is because we actually know our times tables. It all comes down to your times tables. Fractions are about that difficult if you actually know your times tables. Because a great many of you don't, I'm going to give you a little hand here. Over on the side, let's talk about a couple of division rules, because we're going to be doing a lot of division in this unit. And there are some very easy division rules. The first one. Anything ending in 0, 2, 4, 6, and 8 will divide by 2. You already know that, because those are all the even numbers. Yes? Right? That's the first division rule you should know. The second division rule. If the sum of the digits is divisible by 3, then the number divides by 3. What do I mean by that? I'll give you an example. Somebody give me any digit between 0 and 9. 8. Give me another one.
7.
Give me another one. 6. And give me... That's enough. 876. If you add those numbers up, 8 plus 7 plus 6, you get 21, yes? Does 21 divide by 3? Yes. So that means 876 will divide by 3. Everybody understand? Crazy, hey? But it is indeed true. If I divide that by 3, I get 2, 6, 27, 9, 27, 0, 6, 2. 292. Everybody with me? You don't need to remember how to do long division, because you're going to be using your calculator to do your division in this section. But this is a good little trick to have. Okay? Now, some of you know some of these. Some of you had a teacher that showed you some of these, and some of you didn't. I never had a teacher that showed me any of these, so I don't know all of them. Do you understand what I'm saying? I only know a few. All right? I don't know if there's one for 4, but there is one for 5. If it ends in 0 or 5, it divides by 5. And if it divides by 2 and 3, then it will divide by 6. Other than that, I don't know any. If you guys know some, I'm more than willing to listen and write them down. But those 3 are pretty helpful. Or those 3. Those 4 are pretty helpful. Everybody good? All right. So you've got some division rules. You know what a prime number is. So I want you guys to think back to grade 3, and we're going to do a factor tree to find the prime factors. So a prime factor is a factor that's a prime number. Okay? And all you do to find factors is divide. All right? So look at 54. Can any of you tell me any two numbers that multiply together to make 54? 9 and 5? 9 and 6. So you remember Mrs. Bag Crumble would have written 9 and 6. Now, can we stop there? No, because we are looking for prime factors, and both 9 and 6 are not prime numbers, are they? So we got to divide each of them now. What can we break 6 down into? Remember, we're never allowed to use 1 or the number that we are working with. So it's going to be 2 and 3, yes? Oops, I just went to 9. 2 and 3. Are those prime numbers? Yes. So whenever we had a prime number on a branch, I like to circle it because I know that branch is over. Could 9 break down some more? Into what? 3 and 3. Are those prime numbers? Yes, so we stop. Is everybody cool? You all remember doing this? Some teachers go sideways. 6, 9, 3, 3, 2, 3, right? It just depends on who your teacher is. When I make a factor tree, I go like this. 54. I break it down this way. I see that it's even. 2. 27. 3. 9, 3, 3. And I go until I have all prime numbers out here. That's the way I was taught to do this in 1990. This exact lesson. Do I care what you do? No, as long as you recognize you keep going till you have prime numbers. Is everyone cool? Now, I need you guys to do something for me. You're going to do 2 things. 1, you're going to write this out long ways. So this is 2 times 3 times 3 times 3, correct? And you're going to write it out exponentially. What would this be if we were going to use exponents? 2 times 3 to the third. Is everybody cool with that? Easy peasy, right? Right? Okay. Let's do the same thing for 162. Break it down. What are you going to do first? You say that, I see that it's even, so I'm going to use 2. 2 and 81. Yeah? Is that a prime number? So I stop that branch there. Zaro says, can I use 3? Of course I can, because 1 plus 6 is 7. 7 plus 2 is 9. So I could have used 3. Right? And that's fine. Is there a right or a wrong way? No, as long as you keep going till all your branches end. What are you going to break 81 into? 9 and 9. Either of those prime? No, so I keep going. 3 and 3. 3 and 3. And then we're going to write this out in the 2 forms. 2 times 3 times 3 times 3 times 3. And 2 times 3 to the 4th. Is everybody cool? All right. Now, you have already also dealt with these 2 terms. Greatest common factor and lowest common multiple. The greatest common factor is what? No. Don't give me an example. What is the greatest common factor? What does it mean? Exactly what it says, yet people can't explain it to me. If it means what it says, Aiden, explain it to me.
For 2 numbers, you have a list of all the factors that
Yep.
it's the largest factor in number that they both share.
Excellent. And it's really easy to do. You guys did this with very small numbers earlier in life, yes?
The greatest shared factor.
Right? If I said 25 and 45, you would all list out the factors. 1, 5, 25, 1, 3, 5, 9, 15, 45, and you would see that 5 was in both of them. Yes? But the numbers don't end small, do they? How far up can we go with numbers? To infinity, yes? So we got to know some tricks that will find us factors and multiples of big numbers. In grade 4 and grade 5, you learned how to do all this stuff, but you use little tiny numbers. We're going to work with bigger ones now. So here we got some bigger numbers. So as Aiden says, the greatest common factor, which I'm going to rewrite as GCF, which you can see I've got it right there. A GCF is the largest factor shared by a group of numbers. Now, Our group right now is two numbers, yes? 54 and 162, right? So we want to find the biggest factor that those two numbers share. And this is how you do it. You take the prime factorization. I'm going to highlight the word prime factorization in green, and then I'm going to highlight this. These are two different ways of writing out a prime factorization. So to find a GCF with prime factorization, GCF can be found using the prime factorization by listing all the prime factors that occur in your group that are shared. So, is there a 2 that is in both groups? Yes, right there. Is there a 3 that is in both groups? Yes, right there. Is there another 3 in both groups? Yes, right there. Is there another 3 in both groups? Yes, right there. Is that 3 in both groups? No. So when I list all of them that are shared, for GCF at the bottom here, there was a 2, a 3, and another 3, yes? And 2 times 3 times 3 times 3 equals 54. So the GCF of 54 and 162 is 54. Why? 54 is a factor of 54 because 1 times 54 is 54, yes? 54 is a factor of 162 because 3 times 54 is 162. Everybody good? Everybody can find the GCF in their sleep. They have no problem doing it because all you do is write out everything that's shared. The next thing that we're going to do is more problematic. You already know how to do this by using, or from the process of lowest common denominator. To find the lowest common denominator of a fraction, you are indeed finding the lowest common multiple, the LCM, which I'm going to write in green. All right? This is weird because of the way the words are used. A greatest common factor, the answer to that question is the same or smaller than the numbers you are using. But a lowest common multiple is bigger or the same as one of the numbers you are using, even though we use the word lowest. Is everybody with me? So can anybody tell me what a multiple is?
Something that if you use the numbers as given times another number, what it equals to multiple.
Yeah. So if I have a number and I multiply it by another number, then I'm getting a multiple of that original number. Is everybody cool with that? It's hard to explain with generic terms. It's easy to show with numbers. For example, 8 is a multiple of 2 because 2 times 4 is 8. So, everybody good? 8. Okay. So, first of all, we're going to explain this. A lowest common multiple is, and it's weird to say, it's the smallest number Yeah, well, I'm going to use the word factors, which has all of your group as factors. So remember, our group right now is 54 and 162, yes? So there is a number that both 54 and 162 are factors of. You already know what it is if you stop to think about it, but we're going to find out how to do it anyway. And an LCM can be found using prime factorization as well. Okay? But there's a bit of a hitch. An LCM can be found using the prime factorization by listing all factors only once. So in greatest common factor, we had to do what was shared, yes? But in this one, we got to do everything, but we only count the stuff once. So when we are doing LCM, I like to use exponent. I do this for GCF, and I do this for LCM. And here's what I mean. I got to count 2, yeah? Because I got to count everything once. I only need to count a single 2, because that covers both of them. Is everybody with me? Does everybody understand what I'm saying? I'm not counting both of them. I only have to count the numbers once. Everybody good? Okay. I got to count 3, don't I? How many 3s must I count to cover all of the 3s? How many 3s are here?
7.
Okay, but I only have to count them once. So if I count this 3 4 times, does that cover those 3s?
Yeah.
Yes. Does everybody see how it works? I only count the numbers once. So the 2 covers that guy, and the 4, because it's a bigger exponent than the 3, covers that guy. Is everybody with me? So for LCM, I had a 2 because that covered everything. I had 1, 2, that fit in both. And I had 3 to the 4th, and that covered the 3 cubed, right? Which equals 162, which I told you already knew because we already talked about how 3 times 54 was 162. And the lowest possible multiple of 162 is 162 because 162 times 1 is 162. Is everybody good? Go to the bathroom, get a drink, whatever. Now, turn the page over, and we're going to do 4 of these, but I'm going to add in the last one, I'm going to add 27 to the list. So we'll do the first one together, and then I'll shut up. Start with 36. How do I break that down? 2 and 18 would be just fine. And I'd stop at 2, right? Why, Elijah? It's a prime number, so I'd stop there. Do I have to go 2 and 18? How many other people chose a different number for the first level? What did you choose, Avery? 3 and 12. What did you choose? 9 and 4. You chose 6 and 6. Will it matter? No. Whatever you chose, follow it all the way down. I'm going to keep working with Elijah because he said 2 and 18. So what would you break 18 into, Elijah? 3 and 6? 3 and 6. 3 is prime. I stop. Then what do I do with that? 3 and 2. And then what do I get? 2 squared times 3 squared. Right? Everybody agree? Okay. Then we'll do 120. What are you going to break 120 down into? You want to do 60 and 2? Okay. Stop. Now what are you going to break 60 down into? 3 and what? 20. 3 we're going to stop. Then what's 20?
5
5 and 4. 5 we're going to stop. Then what's 4? 2 and 2. And what do I get there? 1, 2, 3 2s times 1 3 times 1 5. Is everybody cool? Can everybody do that? All right. Now we got a GCF and we got to LCM it. I like to use blue for the GCFs as much as I can. So, is there a 2 in both of them? Yes. How many 2s are in both of them? That guy's got 2, that guy's got 3. So if I actually wrote it out, it would be 2 times 2 and 2 times 2 times 2, yes? And only the first 2 are in both, correct? So it's 2 squared because it's the smallest one. Everybody good? Is there a 3 in both of them? How many? 1. Is there a 5 in both of them? No, so we stop right there. What is 2 squared? 4 times 3, 12. So the GCF is 12. Can everybody do it? Okay. LCM I'm going to do in green. LCMs, now I'm looking at the biggest exponent. And I got to count them only how many times? Once. So, there's 2's in both. What's the bigger exponent? 3. And those 3 3's will cover that guy's 2 3's, right? So, there's 3 3's, or 3 2's, times. How many 3's? No, 2. Because that guy's 3 squareds covers that guy. And we got to count everything once. So what's the last thing I need here? A 5. What is 2 cubed? No. 8. What is 3 times 3? What is 8 times 9? 72. 72 times 5 is 360. So those are the GCF and the LCM. Is everybody cool? Okay. You guys try B. You can keep going, but at the very least do your own factor trees right now. Okay, if you can get all the way down to GCF and LCM, by all means do it. But if you're still a little hazy on this, try it and see what happens. If you have no idea, at least get to here where you've got it listed. Now, please notice what I've done here. The one we did together, I used kind of bigger numbers, right? 120. The one I'm getting you to do on your own first has smallish numbers. Everybody should have been able to get to here. I'm going to just wait a second to make sure you all can. Maybe I didn't give you enough time to get there, but that's different than not being able to get there, right? Can everybody make the connection from these two numbers to their factors to their lists? Can everybody do that? Everybody is good? Okay. GCF. What does that count? That counts only shared. So, what is shared between both of them? There's 2's and 3's. How many 2's are shared? Just one. So this guy can only cover 1, 2. So there's 1, 2. How many 3s are shared? 1, because this guy can only cover 1, 3. So the GCF is 6. Is everybody good? All right. Like I said, GCF is not usually a problem. LCM, that is everything. How many times? Once. So, we know 2 occurs. How many 2s occur here? How many here? 3. Does the 3 2s here cover that guy's 1, 2? Yes. So I got to count all of them. 2 cubed. How many 3s occur here? How many 3s occur here? So I got to count all of those 3s because that guy's 3s cover that guy's 3s. Is everybody good? 3 squared. What is 2 cubed? 2 times 2 times 2. 8. What is 3 squared? What is 8 times 9? 72. Is everybody good? And indeed, 18 times 4 is 72. And 24 times 3 is 72. So it works. Is everybody good? All right. Do 45 and 75 by yourself. They both end in 5, so it's a real good number to start dividing by. 5. You guys go ahead and make those trees. Try to do the GCF and the LCM completely by yourself. I'm going to turn off the screen behind me, but I'm going to make the factor tree and do all the work, so the video tonight will show all this work. But the next thing you guys are going to see is just everything done. You won't see the working through of it. Everybody okay with that? Okay. When you feel you have an answer, other people are still writing, go ahead and see if you can figure out D. And in a second, I'm going to put up the answer. You can see if you did it right or not. Remember, GCFs are the same or smaller than your group of numbers, and LCMs are the same or bigger than your group of numbers. I'll wait another 30-odd seconds, and then I will ask if anybody wishes to give their answers to C. Again, if you finish C, try D. Would anybody like to give me their answers to C? Anybody want to give it a shot? Zaro. GCF is 15 and LCM 225. Let's see if he's right. Indeed he is. Does everybody see how it is done? Now, unlike grade 3, we are going to use this knowledge tomorrow to do more math. This is not the end of it. This is barely the beginning. Is everybody good with C? Does everybody see how it worked? Yeah? All right. So let's look at D. Do you think anything changes when we have 3 numbers? No. We just have to make how many factor trees? 3. And then we're going to have 3 lists, right? So let's do so. 35 is what? 5 and 7. Oh, that was an easy one. 84 is what? 6 and 14. Cool. Then what? 2 and 3 and 2 and 7, right? So 2, 3, 2, 7. And 27? 9 and 3, 3 and 3, right? So I now have 3 lists. I've got 2 squared times 3 times 7. I've got 3 cubed. And I've got 5 times 7. Is there a GCF? No. Why? I can see that 3 is right there and there. That's common. But it's not common to all of them. I can see 7. That's common. But only to those 2. So what is the GCF? No. No. What's the number that is common to every single number? 1. So the GCF equals 1. Because 1 times 35, 1 times 84, 1 times 27, right? Now, oh, I should have done that in blue. Sorry. GCF equals 1. Why? Because there's no common factors. But what's the LCM? It's going to be a giant number, isn't it? How many 2's do I have to count to cover all of these 2's? 2. 2 squared. How many 3's will cover all of my 3's? I don't need to count. I never need to count something twice. Those 3's will cover all my 3's, yes? So 3 cubed. What about 5? 1 5. And what about 7's? 1 7. 2 squared is 4. 3 cubed is 27. Times 5 times 7. I'm going to do that one in my head. 35. Can I do that in my head? Well, I can. What is it, though? 3,780. And that is the lowest common multiple. So if you ever had to add up those 3 fractions, your lowest common denominator would be 3,780. Is everybody good? Aiden. That's fine. Well, then you did something poorly. 27 can't be divided by 7. But 27 can't. 35, 84, and 27. You were reading when I added the third number. Again, not something that ever bothers me, but it does when you don't pay attention to the actual work I give you. Now, your homework tonight is page 90. There is 3 minutes left before the 15-minute time I'm giving you for your quiz. Your quiz should not take you 15 minutes. It should take about 10 seconds a question for the first part, which is 8 questions. So that should be about a minute and a half. and maybe 2 or 3 minutes per question on the back. At 3 minutes each, that's 7.5 minutes to do this whole quiz, and you're in class for another 20. When you finish the quiz, what should you work on? Page 90. On the quiz, all you need is your name. If we have enough time, we'll mark it today, but we'll more likely mark it tomorrow. Okay? Tomorrow, oh, I lie. We won't mark it tomorrow because what are we doing tomorrow? Our cumulative exam on what? Measurement and trigonometry. Is it anything to be stressed about? No, why? Can it lower your grade in any way? No. Can it help your grade? Yes. So do you have anything to lose? No. So should it be anything that you are stressed about? No. Check out the sassy font on this one. See what it is? See the font? They're eggs because it's Eastery time. Put your name on it. Do the best you can. There are 8 on the front page and 2 on the back page. You may use your calculators to do whatever you need to do. But you shouldn't need them too often with this big. When you are finished, you go back to page 90 in your textbook or your workbook and you work on it. As you can see, when I was making this workbook, it was close to Halloween when I made this page. That's why there's gravestones, even though it's not Halloween now. Huh? Oh, they're eggs on the quiz, but these aren't eggs. Those are gravestones.